All right, welcome back. Back again. 10 vibes back. Hello, friend. All right, angle relationships in circles. Woo, more good stuff. This one kind of plays right off of the last section. And so, last book actually had it all as one section, so shouldn't be too bad. But today we're talking about chords intersecting tangent lines or other chords. What relationships exist among the angles and arcs formed? All right, so find the angle and arc measures and use circumscribed angles. So here we go. First theorem, 1014, tangent and intersected chord theorem. So when you have a tangent, whoops, and a chord that intersect, essentially what's happening is you have an inscribed angle again, because the angle's vertex is on the circle. So it's the same rules as last section. The arc, in this case, if I go BA, it's going to be half of angle 1, and the arc over here, ACB or BCA, is going to be half of angle 2. So let's see what it looks like. All right. First problem. We've got example 1A. Line M is tangent. Find the measure of the red arc or angle. So in this case, we're looking for the angle. And guys, all you got to do, trace it, as they say in Canada. And it's half of 130. So you take 130, you cut it in half, 65 degrees. So same rule as last section when you had an inscribed angle. On the circle, half of the arc it opens up to. And in part B, you're given the angle. It's a big angle here, 125 degrees. So you just double it, man. So you double it. And so the arc in red would be 250 degrees. All right, try some monitor progress. Pause it, and I'll catch y'all in a sec. Okay, hopefully your monitor progress looks like this. You've got 105-degree angle that would be opening up to the 210 for number 1. Number 2, double your 98 to get 196. And then 3, double your 80 to get 160. All right, so tangents and chords make an inscribed angle, same rules apply. All right, now we get to the good stuff here. You've got, where can the angles meet in the circle? Well, they could be on the circle, that's inscribed. They could be chilling inside somewhere, or they could be outside. So different rules apply. You already know what happens here. We just cut it in half, or that's the relationship. It's half of the arc it opens up to. What happens in these other two cases? Well, let's see. 1015 theorem, angles inside the circle. Pretty cool. Angle 1, you just look at the two arcs that the angle would make because they're vertical angles. So they're going to be the same on each side. And so it makes an arc over here at DC, makes an arc over here at AB. You just want the average. Add them up, divide by 2. Similarly, if you're looking at angle 2, you would go with arc BC and arc AD and find the average of those two. Add them up and divide by 2. Now the only difference when you get outside the circle, angles outside the circle, everything's about the same, except if you notice, now you want the difference of the arcs as opposed to the sum. So if it's inside, you're adding them together and divide by 2. If it's outside, you're subtracting them and dividing by 2. And you always want the bigger arc first. You're always going to have a positive answer. So as the angle is formed, the rays go, and so when they exit the circle, that arc is going to be larger than when they enter the circle. So you're always taking the bigger arc, subtracting smaller arc from it. If you've got two tangents, then the two arcs together make up the whole entire circle. So it's pretty cool. So like this arc and this arc together make 360. So sometimes they'll give you less information on one like this. Like if they give you this as 200, well, then you know that that would have to be 160. And then sometimes they'll give you the angle, and you have to work backwards and find the arc, but you're just using these equations every time. And then again, if you've got two secants, then again, it's bigger arc minus smaller arc, divided by 2. So let's see what it looks like with some problems here. I got 99 problems, but this section ain't one. All right, so where is my angle? It's inside the circle. So that tells me that x is going to equal half of the 2 arcs added together. All right, so example 2, I just take 130, 156, add it up, divide by 2, x is 143. And then the x is, the angle is that you're missing is outside the circle now. So the only difference is you still start with the angle equals half of, now subtract the 2, find the difference. All right, so subtract 178, 176 divided by 2, x would be 51 degrees. 51, baby. All right, so there you go when it's inside outside. Let's take a look at the monitor progress. The next 2, pause it. Now again, they might trip you up and give you the angle. Don't freak out. Just work it backwards. Pause. All right, so working it backwards. And number 4, a little tricky. 102 was over here, so I subtracted it from 180 to get to 78. Because together they're making a line. Right, so if you have 102 on this side, you have 78 on that side. So you do a little bit of work, and then you were given the angle, so that's going to go on the left-hand side by itself. So the best thing to do, easiest thing to do here is just double both sides when you're at this stage, times 2, times 2, then that gets rid of your fraction, and then subtract 95. Over here, 30, again, goes on the left, working it backwards, your variable, your larger arc, so put it first. And double both sides again first, and then add 44, and whoop, there it is. All right, next concept is when you have a circumscribed angle, is an angle whose sides are tangent to a circle. Watch how cool this is, it's real easy. Circumscribed angle theorem, 1017. Measure of a circumscribed angle is equal to 180 minus the central angle that intercepts the same arc. So you got these tangents, you have a central angle formed right here, and so the relationship is just that those 2 angles are supplementary. All right, you got 180 happening. So let's see what it looks like. Real simple. In example 3, part A, well, I know I got tangents, so all I have to do is take 180 minus 135 to give the x. So x would be 45 degrees. That's simple. A lot of this stuff's easy. It's just by itself. It's just there's a lot of different things you got to memorize. Now in this next one, this one's cool. Check it out. So it's not quite set up the same because x is over here inscribed. But since it's opening to the same arc that h is creating out here, well, check it out. What would your central angle be? Your central angle in here would be 150. Let me make it a little bit bigger, guys. Hold on. All right, so watch how we attack this one. So your central angle would be 150. So that means this arc would be 150. And why would it be 150? Because the 30 and that angle, same concept as over there, has to make 180. So you'd start this party by taking 180 minus 30 to get 150. And so now that you know this arc is 150, well, trace it backwards like last section. X is opening up to 150, so x is going to be half of that. So it's just half of 150, or 75. All right, pause it. Take a look at those next 2 problems. All right, here we go. First one, easy peasy, baby. They add up to 180. So the x is 60. And in number 7, you gotta do that same thing we did last time. So I know that the central angle would be 130, so this arc is 130, and since x makes a 130, and it's on the edge of the circle, it's inscribed, then I'll cut it in half, so x would be 65. All right, final concept today, my friends, and it's just an application throwing back some SOHCAHTOA at you. Northern lights are bright flashes of colored light between 50 and 200 miles above Earth. A flash occurs 150 miles above Earth at point C. What's the measure of arc BD, the portion of Earth from which the flash is visible? Earth's radius is approximately 4,000. So essentially what we did here is got ourselves into a situation where we've got our right triangle, because tangent and radius form a right angle. You know that one of the legs is 4,000 and the hypotenuse is 4150. We want to know what this arc is, so we're going to have to trace it back and get what this central angle is. Then I could just double it, because then the other side would be the same over here. So, how do I get x? Throw it back. I got adjacent and hypotenuse. A, H, that's your cosine. So the cosine of x equals adjacent over hypotenuse. So we throw it into our calculator. We go, I think I did it up here in this first one. Make sure you're in degrees again. And so the second cosine of 4,000 divided by 4150 is 15.5. So x is 15.5 degrees. And then don't forget to double it, because you want the entire arc. So you want both of those angles like we have drawn over here. So x would be about approximately 31 degrees. You can squiggle approximately if you want. All right, so try the last, monitor progress, follow those steps, see what you get. All right, and hopefully you get 4.2 approximately. All right, and there it is. There's second cosine of 4,000 over 4,002.73. In your calculator is like 2.1. So double it, and it's about 4.2. All right, that's a wrap on 10.5. I love you all. Peace.